We are going to look at elements and compounds in terms of what the small particles are like, whether they're atoms, molecules, or ions. And we've looked at this kind of a flow chart here with some different arms that had, mixtures and the different kinds of mixtures. So now we're going to look more carefully at elements and compounds. Compounds can be molecular or ionic, and elements can be atomic or molecular. So most elements that exist in nature have single atoms as their basic units. So that atomic elements is most of the elements that are in nature, such as sodium, neon, these guys. But there's a group of elements that exist as molecules. There are the 7 diatomic molecules, diatomic elements, and then we've got phosphorus and sulfur. So these guys we need to memorize. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And then those are all diatomic, and then phosphorus and sulfur are weird. It's P4 and S8. Why? Because that's what they do. I don't really have a good explanation for you. But here on the periodic table are all of these guys. So if you notice, if we start with element number 7, there are 7 diatomic elements. If we start with 7, they make a 7. See that? They make the shape of a 7. Plus our little baby brother friend hydrogen, who insists on being an exception to pretty much everything. So that's one way to remember those guys. The other is with a silly sentence. Horses need oats for clear brown eyes. Horses need oats for clear brown eyes. The eye is a stretch. Get over it. I should have started farther on the left. H, N, O, blast. I've had lots of other things happen to me. That particular glitch has not happened to me before. There's a first time for everything. 4, clear, that's chlorine. Brown is bromine, and iodine. Whenever we see one of these 7 elements as an element, not part of a compound, but as the element, its formula will be the element symbol with a subscript 2, because that's what they do. Then there are these other 2 guys in the pink here. Phosphorus is P4, sulfur is S8. We've got selenium in there too, but that didn't show up in the previous slide. I don't remember what it is, so we're going to ignore him right now. Any questions? I guess just to go back to that real quick. So 2 kinds of elements. Atomic and molecular. These guys highlighted in yellow and pink on the periodic table, those guys and this guy over here, those are molecular. Everything else is an atomic element. Okay? When we come to compounds, we have molecular compounds and ionic compounds. Molecular compounds are composed of molecules, hence the name molecular compound. So, molecular, molecules. These are usually 2 or more nonmetals. And they contain molecules, hence the name molecular compounds. Examples: water, dry ice, propane. They're individual molecules. So, didn't mean to do that. We got hydrogen, oxygen, 2 nonmetals. Carbon and oxygen, 2 nonmetals. Carbon, hydrogen, 2 nonmetals. Molecular. Ionic compounds, have ions. So ionic compounds contain ions. And they've got anions and cations. You need a positive and a negative to attract to each other. Usually, the cation is a metal. There are some exceptions. Can anybody think of a cation that is not a metal? It's polyatomic. Ammonium, NH4 plus, is a cation that does not contain a metal. But if you see a metal, then you can pretty much assume it's going to be an ionic compound. Now, ionic compounds don't contain molecules. They contain ions, and they form this array in 3 dimensions. They're all just attracted to each other, and so, I mean, if you had to call it a molecule, the whole piece of it would be a molecule. And every molecule would be a different size. So what we refer to for the ionic compounds is the formula unit. That's the smallest electrically neutral collection of ions. The smallest ratio of cations to anions. So when we look at something like table salt, sodium, and chlorine, NaCl, it's a 1-to-1 ratio. So this is not telling us that there's a sodium chloride molecule that has 1 sodium and 1 chloride in it, but that in this whole big array of this ionic compound, the ratio is 1-to-1. Here is an illustration of molecular compound. This is propane, and we see that we have individual molecules. These stay together whether it's liquefied or goes into the gas state. Whereas with an ionic compound, we have an array alternating sodium and chloride ions. So that's an important difference between molecular and ionic compounds. Then there are polyatomic ions. Lots of prefixes. Poly means many, atoms. So these are ions that contain many atoms. Examples, I made you memorize a bunch of these already. So when we look at this one, NaNO3, we look at the first element, it's sodium. Sodium's a metal. This is an ionic compound. We've got sodium ion, and then we've got NO3, that's the nitrate ion. That's a polyatomic ion. It's got more than 1 atom in it. Calcium, CaCO3. Calcium is a metal, and CO3 is the other ion. Okay, more on those later. Much more than you want. So we're going to classify these guys. Atomic element, molecular compound, or ionic compound. So number 1, first of all, element or compound? Element. How do we know? Because we know it's fluorine, it's an element. Most compounds have 2 words in their name, just like most people go by a first name and a last name. Not everybody, but most people. So the fact that this is 1 word suggests that it's probably an element. Also, if we can find it on the periodic table, it's going to be an element. Is this going to be molecular or atomic? Molecular, because it's one of the 7, right? N2O, element or compound? Compound. It has 2 different element symbols. Now, is this ionic or molecular? It's molecular, so MC. I'm not lining these up very well. Molecular compound, 2 nonmetals. How about silver? It's an element, what kind? Atomic. Not one of the 7, so it's ionic. Or phosphorus or sulfur. K2O, ionic compound. Because potassium is a metal. Now that might not be something that you immediately recognize as a metal, so you need to look at the periodic table. It's way over there on the left side. It's a metal. How about NH4NO3? obviously a compound. You look at this and it's got, well, nitrogen, hydrogen, nitrogen, oxygen. Those are all non-metals, right? But what's this guy? That's an ion. That's a polyatomic ion, and this is a different polyatomic ion. This is an ionic compound. We have to recognize those polyatomic ions. Any questions?